Thank you, folks, for joining. Really excited to have this opportunity to speak with the Eckerson Group community about a hot topic, cloud analytics and feeding cloud analytics projects with the necessary data. My name is Kevin Petrie. I am the head of research here at Eckerson Group. We're a boutique research and consulting firm. We're focused on data analytics. I'm joined by Mike Pickett, who is the VP of Product Growth at Streamsets. Streamsets is now part of Software AG. Our talk today is to focus on liberating enterprise data for cloud analytics, insights, and reporting. I'm going to let Mike introduce himself in more detail when I hand over the microphone to him in about 20 minutes. But my background, I've been in technology for almost 30 years, data analytics for almost 15 years. I was on the vendor side for a long time, ran an analytics services team for Pivotal. I was with Attunity, a data integration vendor that was acquired by Click in 2019, and joined Wayne Eckerson with Eckerson Group about 3.5 years ago. Love working with practitioners, helping them figure out how to manage data, how to analyze data for competitive advantage, and really enjoy working with innovative companies. Streamsets is a great example. We've been doing a few different things with them. So to kick things off here, let's talk about the rise of cloud analytics. As we know, organizations have been very focused in an increasing level over the last decade on innovating, launching new projects, new initiatives to engage customers in new ways, to sharpen operations, and thereby gain competitive advantage. There's a rising realization within organizations at the highest executive level that organizations need to use data and need to use analytics in order to compete. And the cloud platforms, flexible cloud platforms, can provide, in many ways, an ideal platform to make that happen. The elastic resources when it comes to compute and storage, the ability to bring in optimized analytics tools, and also tap a broad commercial and open source ecosystem of analytics tools are all reasons to analyze data on the cloud. We've seen a growing trend for multiple clouds. Many organizations are adopting infrastructure from not just one of the three hyperscale cloud providers, but two or even three of them. And they're doing so for a couple of reasons, a few reasons. One is to maybe optimize performance or availability in a given geography. They might gain some pricing advantage or negotiating power, but they also might find that certain environments have a better set of analytics tools than another. Regardless, a lot of analytics initiatives are now taking place on the cloud, and they require data. They require a lot of data from legacy systems. That might be mainframe, that might be SAP, iSeries, traditional operational databases, Oracle, SQL Server, and so forth, continue to power a lot of operational workloads on premises. And due to great data gravity, due to data sovereignty requirements, and the cost of migration, that'll continue. There will continue to be this long tail of operational activity on premises. However, a lot of that data needs to be synchronized to the cloud for analytics, and it needs to be commingled with data from new types of sources, SaaS applications that are powering more and more innovative business units across the enterprise, telemetry sensors that can look at log files coming off IoT sensors or off of different digital platforms for engaging customers, click streams that'll look at different footprints and interactions with customers on mobile platforms or more commonly on websites when we're talking about click streams. So all this data needs to be brought together, and that is an opportunity. It's also a challenge. So once we get data to the cloud, as I mentioned, the cloud itself is not one monolithic destination. Rather, cloud platforms comprise an ecosystem, and there's a need to optimize data and move data and transform it between the different elements of that rich heterogeneous ecosystem. So many organizations are starting to optimize operations on cloud databases, MongoDB, and others. They're starting to optimize their analytics on Databricks or Snowflake, starting to commingle data science workloads and business intelligence workloads and figure out how those types of projects can help each other. You've got a lot of applications, cloud native applications running on these cloud databases, and you've got machine learning platforms. Maybe they're AutoML platforms, maybe they're more sophisticated systems such as PyTorch or TensorFlow and so forth. And all these things are commingling with each other, and they need to share data with one another between clouds, between tools, between platforms, between applications and data science tools. So there's a lot going on once you get the data into the cloud. And this complexity on two levels: one, getting data, liberating it from the on-premises systems to move into the cloud. And then two, figuring out how to synchronize it once it's in the cloud means that you need a lot of data pipelines. Data pipelines, as we know, are these workflows that extract, transform, and load, or maybe use different order of operations. They ingest and transform data between sources and targets. And as we saw before, there are a lot of different data types they need to handle. There are a rising number of use cases, projects, users, and tools that they need to support. So data pipelines have gone through their own evolution. And I sort of view this evolution, this history over the last few decades in three phases. One is the traditional, simpler world was loading data, operational data, tables, records from SAP, Oracle, and so forth to data warehouses. These were periodic batches that supported operational reporting. It was more of a staid, predictable set of activities, and you needed to do it every week, maybe every day, possibly every hour. But it was a periodic set of batch loading. Next, the next phase, which I was a part of working with Pivotal and Attunity, was consolidation. There was a desire, and there still is, to consolidate data, figure out how you can get all your sources onto a cloud, data replicated from all your sources on premises and in the cloud to a single enterprise data warehouse, bringing in batches of data, bringing in incremental updates using change data capture or other types of technologies, streaming from a Kafka or Flink perspective, and supporting BI and this emerging class of analytics, data science, machine learning models, and so forth. So consolidation is still trying to happen. Most organizations now recognize, you know what, in all likelihood, I will not have one destination. I will have multiple destinations. And we've done survey data. We work with folks on the consulting side that say, yes, my environment is getting more cloud focused, but it's also getting more distributed. We're going to have data in a lot of different places, and we're going to need to synchronize that data on a real-time basis efficiently across those distributed, hybrid, multi-cloud environments. So there's a need to, as part of this synchronizing, handle complex real-time data flows, support business intelligence, support machine learning models, and automate a lot of the workflows and the actions so that you can have that real-time synchronization. Something in a class of artificial intelligence that has reached some level of maturity are machine learning models that can be trained to recognize patterns and thereby drive real-time decisions, real-time recommendations or actions for customer recommendations, for preventive maintenance from an IoT perspective, content personalization, and so forth. So there's a lot going on there, and that requires more and more automation of the sophisticated data flows. So modern data pipelines have a lot of work to do to figure out how to synchronize all this stuff. And I won't go through each point on this chart, but suffice it to say the modern data pipeline has a lot of different elements and depends on a pretty rich ecosystem of commercial and open source tools, commercial and open source elements. There's ingestion, where we're talking about extracting and loading data. There's the familiar ETL pattern. There's also change data capture, which will identify and help replicate data that is updated, live record updates, new records, updated records, schema changes, and so forth. And there's the need to stream that, maybe through something like Kafka, that can send it to a target. Then there's also the loading of the data into a target. You can append it, you can merge it. Transformation involves a lot of different types of functions, filtering data, combining it, reformatting it. For a given analytics project, you might want to convert everything into Parquet or different types of formats, but have a uniform format. You can apply a schema to it or structure it. You can also cleanse it, for example, to ensure data quality. So these data pipelines have a lot to do. And we see a desire within enterprises to support a lot of different patterns: ETL, ELT, ETLT with a little t, reverse ETL, and so forth. A lot of languages are at play. And I'd put sort of an exclamation point and maybe a big question mark on AI bots. There's a lot going on with ChatGPT, Google Bard, and different data engineers that are starting to say, you know what, ChatGPT can help me write documentation. They can help me create starter code. And vendors are starting to invest in this area as well. So modern data pipelines are going to use a very rich software ecosystem to invest and transform data across all the different endpoints that I pointed out in my architecture diagram before. We would be remiss not to emphasize the need for data ops. This is an area where Streamsets has invested a fair amount in terms of helping enterprises handle these different pillars of best practices. So the program for data ops includes 4 elements that we've identified and do a lot of research on. There's CI/CD, continuously integrating and delivering pipeline code, using branching and merging of pipeline code, applying familiar principles from agile software development, DevOps, Lean, and so forth. And this can help organizations frequently update and improve pipelines and maintain a single source of truth for both their data and their code. There's the need to orchestrate different pipelines and the ways they interact with each other and the ways that they interact with applications that consume their outputs. There's a need to automate that sequence of tasks as the data makes its journey end to end. Testing is obviously integral to CI/CD, making sure that you're checking data quality and pipeline functionality during development and production. And then monitoring or observability is tracking the execution of pipelines and the delivery of the data and identifying and responding to issues. So we see a lot of enterprise, a rising amount of enterprise focus on this discipline of data ops so that they can deliver the rich, multifaceted, and oftentimes real-time data for cloud analytics. Now, if you think about how to meet the various requirements that I just talked about, there is definitely a pattern where commercial tools are going to help you. Yes, there's a rich ecosystem of open source tools to take advantage of as well, but there's very much a focus on automating these workflows. And what we find is that enterprises are focused more on automating data integration than other aspects of data management. They've moved further along there. And B, best-in-class enterprises are doing that with commercial tools versus homegrown scripts. And I think that helps give us the right lens to understand the advantages of working with a pipeline vendor such as Streamsets. So I'm looking forward to Mike walking through that. So enterprises are automating data integration more than other data management tasks, and the best-in-class practitioners are automating with commercial tools rather than homegrown scripts. So there are a lot of different use cases that this nets out to. Yes, there's definitely a desire with certain workloads, with certain business units to consolidate onto a single cloud platform. There will be companies that are cloud native or smaller and have fewer data sets, relatively simpler environments, and they might want to move everything onto Azure. or move everything from an analytics perspective onto AWS. So there is that use case, and we definitely see that. There's also, what I talked about before, which is synchronizing data across platforms. And synchronizing data across platforms is tricky. It involves a lot of the functions that I talked about earlier. It also involves the need to handle data drift. And I think Mike will be talking about this in more detail. But data drift is, as it sounds, drift in data structures, data values, infrastructure, metadata, semantics. There are many ways in which, over time, the metadata and the various components of a data flow are going to change. And that can create a lot of complications at the far end. You need to make sure that within an analytics platform, you're able to absorb changes to schema. You're able to absorb changes to version numbers on legacy source systems. And so that handling of data drift is an important part of synchronizing across platforms. Data orchestration of pipelines and workflows is critical. We've seen a lot of organizations that are using Apache Airflow for this, just as an example, because the more that you can automate the sequence of tasks related to the data journey, and the more that you can reuse pipeline elements in sort of a Lego fashion, so that the sequence of tasks you automate for one analytics use case could be reused for another analytics use case in a different environment with a different source, a different target. That really helps. So we find that modularity and the ability to create these modular Lego pieces really helps with orchestration in particular. I mentioned before that machine learning has risen as a use case for cloud analytics. I mentioned some of the use cases for that: customer recommendations, content personalization, preventive maintenance for IoT environments. It also helps with dynamic pricing decisions and a lot of other things. And we find that the data and the engineering of the data, the preparation of data to train a machine learning model, then the preparation of data to help expose features within a training set or within a data stream is critical. And so there's a big role for data engineers and also for machine learning engineers once you go into production to help define features within data sets and expose those and transform those so that the machine learning model can identify the right pattern, can say, based on these features, here's the recommendation, here's the prediction. And then once you go into production, there's obviously the need to feed those models. So ingestion of data for production ML is a big use case too. We advise enterprises to do something that seems self-evident and sounds like a cliche, but it bears repeating because we all forget it, which is to prioritize your use cases according to business requirements. It's very important, despite the excitement of using a new tool, to start by saying to business consumers within the business units, what is the business problem we're trying to solve, and what is the ROI of solving that problem? Once you have that priority, you can work back and say, okay, that's why I want to consolidate data sets A through C onto this particular platform. That's why I want to synchronize these data streams across different platforms and so forth. So it's important to start with the business requirements, the business priorities, and work back from there. So as I mentioned before, most organizations are looking to automate, and they're looking to do so with commercial tools. So pipeline tools such as Streamsets can definitely help push you in the right direction to handle ingestion, transformation, as well as orchestration, and so on. So what we tend to see five key criteria to help evaluate data pipeline tools. The first would be performance. What are the speeds and feeds here? Can you deliver the right throughput of data, meet the latency windows that are required? Can you provide the uptime that's required? Now, a lot of that is going to hinge on the cloud compute, the network connections and so forth that contribute to a pipeline. But there is the need for data engineers to make sure that they've got real SLAs for those and test a pipeline tool against it. Scalability is really important. There are certain platforms out there for data engineering that will not scale sufficiently to handle the level of compute or users, sources, and targets that are required. Ideally, you should be able to change a source or change a target without interrupting other things. You want to pull out one Lego piece and put in another in a more modular fashion. Scalability can definitely, that helps enable scalability. Ease of use, we're going to see the Streamsets capabilities in terms of a visual pattern to create the sequences in a data pipeline, and then automate the process for putting those commands into work. We do see a trend for smart prompting, so you can have the user get a suggestion about how to optimize a given pipeline. And it should be clear from the ecosystem charts I showed before, a lot of different data types out there, a lot of formats. It's increasingly not just structured tables, it's also semi-structured or unstructured data. And there's a need for pipeline tools to support that. And then, I talked about before the flexibility to support data drift. So your pipeline tool should really help through these 5 criteria, reduce the risk and the complexity of data delivery to really help liberate it for cloud analytics. Here's what good looks like. If you can design and implement these pipelines well, you can liberate your data for effective and efficient cloud analytics, delivering more value to analytics consumers, providing the agility or the flexibility to meet changing business requirements. We all know that the changing macroeconomic picture, supply chain disruptions, huge change in consumption patterns over the last few years just underscore how important it is to stay agile in meeting business requirements. There's also the ability, if you do it right, to maintain your data uptime and reducing operational risk. And efficiency, you can improve efficiency from an infrastructure perspective and improve productivity. This is a huge one for data engineers and for other members of the data team that need to handle an explosion in business requests, an explosion in data, volume, variety, and velocity, and somehow reconcile those two. So the capabilities that we've talked about here for data pipelines can help meet those requirements and improve productivity. Okay, so I am going to hand over to Mike, and who is beaming in from the top of the headlands there in San Francisco. One of my favorite views, by the way.
Yeah, I wish. Thank you very much, Kevin.
All right.
Well, I get going. Good to meet everybody. Thank you very much for attending and joining us. A little bit about myself. I've been in the data integration space since 2005. I started in the integration market back in the late 90s at a company called TIBCO. Spent about a decade at Informatica. I'm here with one of my ex-colleagues, Adam Bracey, for about 10 years. Then went to Talend, and now I've been at Streamsets software AG company for about 2 years. I love the data integration space. I never thought I'd fall into it, but it is a space that continues to evolve. The cloud has absolutely opened up new possibilities that I think a lot of us had dreamed and thought about, but didn't think could actually happen. And it provides the scale and cost and everything. It's fantastic. So it's a bit about me. What do I do at Streamsets? What's the vice president of product growth or growth? I have an awesome job. I get to look for new market opportunities, trends that are happening. In the acquisition of us with Software AG, me and my team, we get to work on looking at getting complementary technologies together to solve new problems. And one of the areas that we're working on is around application integration and data integration. Another one, which I'm not going to focus on, but I'll touch on, is we're able to unlock mainframe data for cloud analytics. So with that, let me jump in. One of the things that I'm always looking at is, saying, everything's moving to the cloud, it's passé, but what are the reasons for people moving to the cloud now? And really neat article that Deloitte published a little while back. And I think what's topical here is, what are the C-suite people saying on why they're moving to the cloud? And number one is security. And I think it's finally recognized that Amazon, Google, Microsoft, those that focus on this day in, day out, the cloud is now more secure than on-premise environments. They're able to harness and manage and support teams that are 24/7, trying to find cracks in the system and close them up quickly. So security is now the primary reason for moving to the cloud. But the other two reasons, agility and speed, so that letting the lines of business people operate at the speed of what they want to, that's still there. And that agility and speed fuels the ability for new insights and innovations. People can try, fail fast, and fail cheap for ideas. And when an idea pops up that's looking really innovative, they can jump on it. So key reasons to move to the cloud. Now, going around to a lot of chief data analytics officer events this year, it's both people are more than ever really focused on proving and showing business impact. And business impact is really very short and sweet. It's helping companies improve that the analytics and data is making money for the business, helping the company operate more efficiently or save money, and reducing risk and compliance. Every part of the organization participates, but data is at the center of all of this, and that's what's happening today. Now, Kevin had talked earlier about how it's this, iterative and layered approach, and this is the thing about cloud analytics, is that we're able to do things at a much more rapid rate. And if you think about it like training machine learning models, well, how do you train? You figure something out, then you add to it, and then add to it. That's like all data and analytics projects. And so one of the things that I talk quite often about is analytics projects have an insatiable appetite. It's like the cookie monster for data. As soon as you come around the cycle once, there's an opportunity to go back in and come back and in. Now, that's an opportunity to continually improve reporting, get broader views, improve machine learning models. But it's also a challenge because it's incessant and nonstop. Now, I look at it as the first wave of, call it cloud analytics, was very much SaaS applications into your cloud data platforms. And the lines of business solve this. There's a variety of tools out there. I'll even mention them, Fivetran, Tillian, make it very easy for a business analyst to get connected to their SaaS applications and move it into their cloud data platforms for analytics. But there's a challenge, and this is what Streamsets helps companies solve. As soon as you come into behind the firewall, you're talking about decades of infrastructure. And because it's decades old, the data is moving virtually in every way, shape, format. It can be moving over queues. It can be found in files. It could be in custom applications where you need to go and program in to a custom API. It could be in a legacy analytics system, Hadoop or Teradata. It's everywhere. And it's connected into all these different things, decades of hand coding, decades of infrastructure. And it is a challenge just by the nature. So if you think about before, where the business analyst was like, hey, I can connect to the system and I can get my data over in minutes, maybe an hour. Why is it taking so long to get to my enterprise data? Well, it's the enterprise data. It's complex. I just showed an image of that. It's in different formats and shapes, and it goes very, very deep. And mainframes is an example. They are still around. More than ever, they're looking different than our cloud systems in terms of the ability to get access to them. But where they're found, they are at the core of an enterprise executing their business transactions. That doesn't mean in these enterprise application layer, the custom data stores, the MySQL, Oracle, you're talking decades of infrastructure that built up to run the company. This is where some of the most valuable data, we believe, stands for an enterprise to get to. And this is the data that we believe and see so often in our clients, that if they can unlock, their business and data analysts can really now move things to the next level. But there are some challenges and common approaches. One of the things that's unfortunate we do see is when business analysts come and say, I'd like to get this data, I think it's in that enterprise data storage. The answer can just be sorry, don't have time, or please justify it. And that is oftentimes, unfortunately, used as a reason to hold people off. The business suffers because analysts end up trying to do insights and with only a partial view of their corporate data. And so business suffers. The other one is the hand coding. Kevin talked about how a lot of companies, especially on the not best in class, try to hand code everything. This ends up creating a challenge that shows up in the future. It's not scalable. You don't have good transparency. You don't have good control. Is quite often that if somebody moves on and now somebody shows up and it has to go reassess what was done, they have to figure out what was the logic behind something. It's a very difficult way and a brittle way of trying to scale your data infrastructure. And then the other one is, we see is quite common, is especially in large companies have been around for a while, they're trying to repurpose traditional or legacy tools that they used for their prior generation of data integration platforms on premise. They're trying to repurpose them for the cloud. And they just weren't designed for that. And it ends up showing up in some challenges. And this gets into the area of data drift. So data drift happens everywhere, and it's happening constantly. It can be format changes. It can be structural changes, it can be file changes, connections change. As we see clients embrace the cloud, one of the biggest drifts, and it's significant, is they choose to move part of their infrastructure to another cloud provider. How do they do that? This is what drift does, and it is happening all the time. So when organizations or people try to take those other approaches we talked about, using traditional tools that weren't designed for drift, or using hand coding, every time they have change, they're actually introducing breakages that then impact the data supply chain, that impacts their ability to be agile and get good business insight. And so what ends up happening? Well, first off, the business insights slow down. And teams are starting to say, I used to be able to work at a certain rate of productivity and be able to race to the finish, so to speak. And I feel like it's slowing down when I come in and ask for data that's in the core enterprise. This is creating friction between different groups. And you can read out on some of the articles on what's happening is there's a lot of contention going on, and this ends up impacting the frontline people, the data engineers that are on point to be the ones that go find the data assets for the business lines of business and provide it to them. And it is no wonder that these teams these people in these organizations are some of the front line for getting burned out and feeling overwhelmed. There's a lot of turnover. It's one of the highest demand jobs, but it also, unfortunately, in a lot of companies, is a place where a lot of people burn out. Now, we talked about drift. And this is something that Streamset's very proud about. We actually have a patent on our capabilities. And drift happens everywhere. I'd mentioned the infrastructure. The simple example of that is somebody chooses to add Google or Microsoft, and they've been using Amazon. They want to move part of their infrastructure over there. That's one part. But it's the schema. We often talk about how schemas are changing all the time. Metadata can change quite often. One of the areas that we see drift happening is in the area of files. I say oftentimes files have become the lingua franca for passing data around the enterprise. Well, if there's any file that requires human input, it is very common that somebody will start changing the titles of what a column is just to make it a little bit more, call it human readable. That's changing the metadata. If somebody's expecting that file is going to be populated and then loaded up and say something like Snowflake, unwittingly, somebody broke the metadata and they broke it, and that can have impact on how that data is loaded up. And then the data itself. Some of this can be very simple. We talk about how dates are structured, European dates versus North American dates, but the data itself can shift over time. And people want the ability to be able to sense this and adjust to this, because while drift happens all the time, it also, when it's happening, can give people, if they have the right infrastructure, the ability to spot changes that are going on in their infrastructure and their environment, and then use that insight to be proactive and identify new opportunities on what they can do with their data. So our secret sauce in doing this is three things. We have the ability to support what we call the control plane, and that's the brains of the operation. We manage and host that. and the data plane. The data plane is where the data is itself. And we separate the two. And then we do that for compliance, security reasons for our clients. The other is what we call maximally decoupled pipelines. The way we've designed our product, every stage can be independent. That allows you to actually mix and match stages. And I'll show an example of that later. But this allows us to basically make changes in our pipeline or have our customers design logic in our pipelines and change components very easy without disrupting all the other components. And then the fully instrumented pipeline, this is really the ability to have fine-grained insight and telemetry to what's going on so that our customers can monitor and manage their pipelines proactively. We want to look at a graphic of what more on the separation of the control plane and the data plane. The control hub is what we manage in our SaaS service. And that's where clients build, their users will build and operate and monitor their pipelines. It's a graphic design environment. Now we push down the logic for what we're doing into engines. And those engines can be run on premise, and that's common in a hybrid environment. Be run in the cloud, oftentimes in like an EC2 environment, or it can be pushed down for the transformations. One of our latest products is Transformer for Snowflake. They can push the logic of complex or simple transformations to run down in and run natively in Snowflake. No infrastructure involved, nice GUI and design environment to help analysts come up with transformations and all sorts of logic, and it's run natively in Snowflake. Very efficient way of doing things and very much adapts and fits into how the modern data stack and modern analytics is to be done. So let's take a look at some of the product capabilities. So we talk about the Streamsets pipelines. We can adapt and we work with any type of pipeline, be it a streaming, be it a batch, or change data capture. We can connect to virtually any data source, be it static or dynamic. And these pipelines that you see here it's one design environment for all of these different connection patterns. So that means that for a data engineer, they have one platform they can work with if they need to work on integrating something from a Kafka queue, for instance, and then moving it into Snowflake. That's great, one design pattern. If they now want to go work with something, say Oracle CDC, and they want to get that data up into Aurora, same design pattern. They don't have to learn anything else. And they can just work in one environment, very simple, straightforward for them. The processors is where we bring in some of our secret sauce. We have over 70 of these available, and this is bits of predefined logic that they can string together in a pipeline to create a common output format. And that becomes relevant in a second. I'll talk about that in a bit. But these can be put together. This is where they can do some quite creative things. They can actually enrich data in the pipeline. They can do all different types of things. And these are where some of our clients actually put together common logic and say, this is the pipeline that gives us this format, and this is how the data is going to be output. Now we want to take this pipeline and deploy it across hundreds of different sources. They can do that very easily in an automated way, and they know that they're going to get a consistent output, but they can easily change the sources that they're connecting to. We also play really well with code. We know it exists, and one of the things is people can write Python, JavaScripts, and easily incorporate it into our pipelines using Streamsets processors that make it simply either available to be dropped in or brought in via a simple API call. And then this is the power of being able to swap out sources and destinations. What you see here is logic that's built up within a transformation logic. And if somebody says, hey, look, my data is now in Google Cloud Storage, not in S3, I just swap out the origin. Nothing else has to change throughout the rest of it. Very common as people move and migrate to the cloud, they'll start with something, pulling data in from a local file, and then the files end up moving into it being loaded into, say, S3. And so that's the new origin for them. They just add that, they just swap out the origin and away they go. Same can be said on the other end also, swapping out the destinations on what they want to do and where it's going to be processed. So we really give clients the ability to be very agile with this infrastructure And this is what we believe is super critical in adopting and embracing, kind of call it the cloud ethos and the cloud pace of change. It's going to be changing always. You want to be working with infrastructure that can change with you at the speed that you need to change and doesn't hold you back. Mentioned we manage this as a cloud infrastructure. It's always on, and it runs in Amazon, Microsoft, or Google. Simply log in and invite folks to go www.streamsets.com, request a demo. If you're a Snowflake user and you want to try out the transformer for Snowflake, that's just available on the Partner Connect. We welcome you to go give that a shot also. But it's an always-on cloud service. We take the management of the infrastructure off your plate so that teams can focus more on helping get data to the people that need it in the lines of business, so that they can do greater focus on providing greater impact for the operations. And with that, I would like to say thank you very much. Really enjoyed the opportunity to speak with you. Thank you, Kevin. And I think we'll open up for Q&A.
Thank you, Mike. Excellent. Okay, so folks can submit questions through the Q&A tab here. I do see, I see a couple of questions. Mike, I can hand to you on this one. How does Streamsets play with other software AG products? You're part of a bigger company now. What are they? What's the synergy?
Near and dear to my heart. So if you're familiar with the software AG products, it's a broad portfolio. So let me go through a few of these things. So the first is software AG has a product. It's called Connects. And I'd mentioned that's the mainframe technology. The Streamsets and the Connects business units, we are now combined. We're one business unit. And so we actually have a product called Streamsets Mainframe Collector. It draws upon a lot of the capabilities in the Connects product, but it is a very nice and well-integrated solution that allows data engineers, data analysts to go explore what data assets are on a mainframe. And then they can choose to move it up into the cloud environment of their choice very easily. And we actually are able to do this. We don't cut the mainframe team out of the picture, but we only engage the mainframe person when it's determined is what's the frequency that we want to move this off, et cetera, et cetera. So it's a really neat solution that's there. The other thing is, let's talk about web methods, which is probably one of the most common solutions we hear from or that people will know of Software AG, and that's an application integration platform. We have a really nice example of where there's a lot of data moving around web methods between applications. Very easy for that data to be pointed and loaded into a cloud data store like Snowflake. And then once it's in there, it automatically triggers a Streamsets transformer for Snowflake event that takes care of data, call it data processing, data enrichment, once it's in the destinations itself. So those are some of the two core products we're working on right now. There's other areas. There's process mining, ARIS, and Cumulosity, which is an IoT. And those are also areas that we're looking at, but they're going to come secondary after these products that we're working with.
Excellent. So I see another question here. And Mike, actually, it's to you. How is Streamsets different from other data integration tools? That's from Kartik.
Let me run through a couple of different categories of tools. And this is my point of view on the market. There's data ingestion, what I would call is SaaS application to cloud destinations, Stitch, which was acquired by Talend. There is Fivetran, and there's Matillion data loaders. In all those products, they're really designed to connect to SaaS applications and put it into a cloud destination. And the data goes and moves across their infrastructure. There's advantages of that. I'm not going to argue it makes it very easy. There are some disadvantages, though. One, they don't connect to they don't connect to it in a really secure way. You typically need to request a tunnel through the firewall if they're going to access data sources behind the firewall. So that's not really a applicable use case. And again, is data going across and through their environments? in companies in a lot of regulated industries, and actually even non-regulated industries, but companies that are sensitive about the data, that's not an option for them. Then there's traditional, what I call data integration tools. And those, Talon, Informatica, those tools were designed and do not adapt to data drift in the way that we see the market requiring data infrastructure to operate today. So I can speak from experience. Clients that implement those and then try to repurpose them in a highly dynamic environment spend a lot of time trying to debug their tools when things happen and when things change. And then there's also a class of tools like just change data capture tools. And what they do is just change data capture, but they don't do any of the data shaping or manipulation or enrichment along the way. And so what they do one thing, but we can do that also, but they limit out on functionality that they can provide. Adam, if you felt I could be happy to jump in.
No, I think you addressed everything. Thanks, Mike.
Oh,
Excellent. Okay, so another question here. I get excited about this stuff, as Mike knows. So the question is, how do LLMs and ChatGPT impact data engineering? Mike, do you want to go first, or should I?
I'm going to let you, because you and I talked about this, and you're ahead of that one than I am. I'm still watching and learning. Go for it.
Okay, so I'm working on a report on this, and probably half of data engineers are already using ChatGPT to assist their work. It's a sole survey about 6 weeks ago that said 42%, and they're using it for product documentation or a documentation of pipeline code. They're also using it to create starter code and help with prototyping. So there's a lot going on. There's also investments on the vendor side. I think a common pattern will be that organizations want to create smaller LLMs with more governed and high quality inputs, and use that to provide prompts to data engineers that can help them write code faster, get started. Big caveat is inspect the outputs of LLMs, because the expert data engineer needs to make sure that they are correct and that they're tested. So a lot going on there. It's a huge separate topic. Mike, if you want to address that, great. I do see another question here from Kartik as well.
Yeah, I just as our head of products team of SpaceX is going to be much more is obviously there's ways to look at AI and how do you help facilitate and proactively guide data engineers on what their pipeline, like here's what your pipeline should be based upon your source and destination, right? There's all sorts of ways to do that. I personally am super excited about it, but it's not that I'm still in learning mode. And Kevin, I'm gonna be looking forward to your publication. So
yeah, it's a real-time learning process, isn't it?
Yeah.
Changing fast. Excellent. Okay, so Kartik, thank you, Mike. Any plans for Streamsets to do data observability?
Yeah, it's an interesting topic, and data observability, you can look at it one way, and in some ways I'm like, oh, that's interesting. That sounds very similar to what we used to talk about with data quality, and but it's really into data freshness. And it's what's old is new again, and there is a different approach. Short answer is yes, and we have some data observability today in our topologies and stuff like that. But the short answer is yes. The longer answer is what's coming. And we also recognize need to work with a variety of tools out there, but that is a space that I find interesting. And that's some of it when people come in and say, oh, it's totally new. I'm like, oh, well, it's new in this environment and its approach is different, but the impact's the same and the need is the same. And it was driven by what things that we learned before. So.
Yeah, it's a great point. I think data quality has been a problem we've been trying to solve for 30 years.
Yeah.
The new data observability tools are sort of more in a cloud context and applying machine learning, anomaly detection, that kind of thing. But it is a familiar business problem and a familiar set of techniques in a lot of ways.
Very relevant. There was a point maybe 10 years ago where somebody was at it was a Churchill speak, and they said, oh, with big data, you don't need to care about data quality. And I was like, wait, what? You always now there are things, and I'll encourage people to think about this. One man's garbage is another man's gold. If you think about collecting all your enterprise data, when you're doing financial reports, data quality, you need to get absolutely exact. Well, if you're now going in and you're the data scientist looking to figure out where anomalies are being introduced, you want everything. Like you want the most raw data. But data quality is always important. It's always important for different constituents. And I don't think it's fair to say anything like nothing's needed or not, absolutes. The coolest thing about what the cloud provides is here's the raw data. Now, any of you can come back to the raw data to use it for your final conclusions and learn along the way. But you have the raw, pristine data just as it came out of the original systems. And I think that's very valuable. Companies are still finding innovative ways to use that.
Great points. Good. I don't see other questions here. Great discussion, Mike. I enjoyed this. And
Thanks.
we welcome continued dialogue from anyone here. Feel free to ping us or locate me on LinkedIn and let's stay engaged. But Mike, thank you very much for the opportunity, and to Streamsets as well.
Yeah, thanks, Kevin. Really enjoyed it. Thanks, everybody. By all means, reach out. We'd love to work with you and invite you to give our product a run for its money.
Sounds great. All right. Have a great day, everyone.
Bye now.